So this week was interesting and challenging at the same time for me.
We were introduced to smart contracts, Solidity programming language, and
the experience has been quite sweet. I just like everything I've learned so far.
I'm talking about DApps, and DApps are a short form for decentralized applications, DApps, right? So what are decentralized applications, DApps? Decentralized applications or DApps are applications that are run on the blockchain or peer-to-peer network, right? And this gives them advantage over traditional applications, right? In terms of security, in terms of transparency, and in terms of user control. There are two key components to the applications, blockchain and the smart contracts. And then advantages of DApps are decentralization and transparency. Applications of the applications in finance, as in decentralized finance, in gaming.
What are smart contracts? Smart contracts are self-executing contracts. They are basically agreements and terms written into lines of code, and these are run on the blockchain, like blockchains like Ethereum, Solana, and the likes. Okay, so what do smart contracts do? They are self-executing contracts, and just like in the Web2 space, where we have the business logic written in either Java or other programming languages, in the Web3 space, smart contracts form the basic of the business logic. So they basically power DApps, decentralized applications. And the importance of smart contracts are they enable applications or decentralized applications to be run trustless, seamless.
Solidity is an OOP, an object-oriented programming language that writes smart contracts on the EVM chain. And Solidity are like statically typed language. It means that you have to specify the data types in Solidity. And these data types, there are actually two types, which are the value data types and the reference data types. So for the value data types now, we have the integers, we have the Boolean, we have the bytes, we have the enums. Now, these data types, most of them, they have the default value, like the Boolean, I think it's false, the address, the 0x, and so on. Now, let me explain the data types. For Booleans are just like normal programming languages. Boolean are just truth and false statements. They return true or false. For address on the Ethereum is actually like 20 bytes, your normal Ethereum address. And there are two types of addresses. And we also have the enums. The enums are their data types that you can actually define them, and so on. Also, we have the references. Now, the good thing about the data types, for the value data types, you just store it in the memory. Like for every value you create, you are going to be creating another copy. But for the reference data type, you're actually managing the memory. Like when you create a reference data type, you're pointing to the memory, not the storage itself. Examples are the strings, the arrays, the structs, and the mappings.
This storage is used in the EVM to store permanently data types, right? That could be your integer, your addresses, and the rest, right? While memory is used to store, but memory is not permanent. So if you're writing a variable in a function, that variable in that function is going to be saved in your memory. While if you are writing a variable at the contract level, that variable is going to be saved in your storage, and saving in the storage is permanent, while saving in your memory is temporary. So whatever you save in memory is being lost after the function you call in the contract is fully executed.
For more updates, like, share, and subscribe.